What's going on, guys? Let's look at this problem right here. Here this question is asking a 6 microcoulomb charge is placed at the origin and a negative 4 microcoulomb charge is placed 2 meters to the right. A third negative 8 microcoulomb charge is placed on the x-axis 2 meters to the left of the first charge. What is the force on the second charge due to the other two? Okay, now let's look at this one through a diagram. Okay, let's go ahead and draw the diagram first. So first they are saying that we have a 6 microcoulomb charge is placed at the origin. So this is positive charge and this is placed at the origin, and then negative 4 microcoulomb charge is placed 2 meters to the right. So here we have negative 4 microcoulomb. Negative 4 microcoulomb, it's 2 meters to the right. So this is the distance is 2 meters. And also we have a third negative 8 microcoulomb charge is placed on the x-axis 2 meters to the left. So this is, here we have another negative charge and that is placed 2 meters from here to here, and that is negative 8 microcoulomb. Okay, so these are the charges we have, and this is first charge, so we call this one Q1, and this is second charge, this is going to be Q2, and the third charge is this one Q3. Okay, so we have 3 charges, and the main question is asking what is the force on the second charge due to the other two. So we are interested in finding the force on this second charge in the Q2 due to the other charges. And we know that charges, if the charges are opposite, they will attract each other, and if the charges are same, they will repel each other. If we look at Q1 and Q2, Q1 is positive charge, Q2 is negative charge. So the force of the Q1, if the charge is for Q1, that will move toward this one, but since we are interested in this is negative, this is positive, the force due to Q1 on Q2 is going to be in this direction. So this is the one we are interested in. We are interested in this charge, so the force is going to be in this direction, so that's going to be F12. And also we have to find out what is the force due to the Q3 charge. Q3 is same charge, so when we have same charges, that will repel each other. So the force on Q2 due to Q3 is going to be in the opposite direction. It will not go through this direction, it will go in the opposite direction, and that's going to be F23, right? F23. Now the question is, what is the total charge? So due to the other two mean, they are asking for the total charge. Now to calculate the total charge, we just try to add both of them. So F total is going to be F12 plus F23. So one of them is like, here we have negative direction and positive x direction. So one of the, after we calculate this one, this is for the magnitude. After we calculate this one, this F12 is going to subtract because this is in the negative x direction. So after we calculate that one, we will know that. Okay, now let's go ahead and do the calculation. Let's go ahead and find what is F12 is. Now to find out F12, we have to look at the charges Q1 and Q2. K is what? 9 times 10 to the power of 9. And then Q1 is 6 microcoulomb. So this is going to be 6 times 10 to the power of minus 6. And Q2 is negative 4 microcoulomb. But since we are looking at the magnitude, we just have to keep the positive one. Right? So this is just the magnitude. So 4 times 10 to the power of minus 6 divided by the distance between that is 2 square, 2 meters square. Okay, let's avoid the unit for now, because if I place the unit, I have to place it for everything. Okay, if you calculate this one, you are going to get 0.054 Newton, right? That's the first, and that is in the x direction, but you can see this F12 is in the negative x direction, so we have to put a negative sign right here. Now let's look at the next one. Next one we are interested in is F23. Let's calculate the magnitude first. To calculate the magnitude, we use this equation, that's K Q1 Q. For this one is going to be different. So let's write the equation for this one first. F12 is going to be K Q1 Q2 divided by R square, and also it's better to write R12 square because the distance is going to be different when we consider R23. So this is R12 and this is the bottom one is going to be R23, Now let's create the equation for this one. This is going to be k q1, actually q2, because we are interested in the force due to q2 and q3. So q2 q3 divided by the distance is going to be r23 whole square. Okay, now let's go ahead and plug the values. K is what? That is 9 times 10 to the power of 9 multiplied by q2, that is 4 microcoulomb, so 4 times 10 to the power of minus 6, and q3 is 8 microcoulomb, 8 times 10 to the power of minus 6 divided by the distance in between. So from here to here the total distance is 4 meter, right? So this is going to be 4 square, and if you calculate this value you're going to get 0.018 in the x direction. Since the direction is, since this is in the positive x direction, this is what we are looking for. This is in the positive x direction, we are going to have the positive answer, and this is our with the direction, right? This one is with the direction and this one also with the direction. Okay, now that's it, and we calculated F12 and F23. Now all we have to do is just add them together to find out the total force. F total is going to be what? F12 is negative 0.054 plus 0.018, and if you add them together you're going to get negative 0.036 Newton in the x direction. This is in the negative x direction, so that's going to be our final answer. I hope this helps. Thanks for watching.